Hello, everybody. I'm Milutin Stojanovic from Helsinki Institute of Sustainability Science. I hope you're enjoying this conference from some nice place, as I certainly am. I'm going to talk to you today on divergent approaches to sustainable food systems research, with particular focus on value assumptions as a source of controversy. We will first cover why food systems are important and try to illustrate the contested states of current research on sustainable food systems. We'll use the example of land sharing versus land sparing debate to illustrate this. And then we're going to go to a broader epistemological assumptions driving the research to see how they're connected with topic of normativity in sustainability science. We're going to cover two research frameworks, meta-research frameworks. Traditional one separating epistemological from ethical issues. And we are going to argue for the other one, which is a hybrid take on values. Finally, we'll see some lessons of how to move the sustainable food systems research forward and find some requirements for good sustainability research. So, food systems are a main, or probably the main source of environmental problems. Estimates for greenhouse gas emissions range from 20 to 35%, with some studies arguing that if you cover things from mining to factory, from factory to the plate, the estimates may rise even to 50% in some cases. Food systems are a major cause of environmental degradation, particularly of chemical pollution, but also of interfering in what is called the biogeochemical flows, particularly phosphorus and nitrogen. Potentially one-way street. At the same time, food systems cover already 40% of terrestrial land, and they are expanding. The rest of the planetary land is mostly cities, forest, mountains, and deserts. So there is not much land left. At the same time, food systems use around 70% of fresh water available. At the same time, they are probably the main driver of biodiversity loss, and institutes such as CPES are arguing for current 6 mass extinction ongoing in the species in general, but at the same time it's coupled with tremendous loss of intra-species genetic diversity, with crop genetic diversity being reduced by 3/4 in the last century. At the same time, food systems have varying economic and social impacts. I will mention just some of those. We are witnessing the unprecedented financialization of food systems, particularly the recent mega mergers in agri-food sector. This is coupled with disintegration of rural communities, which is hard to measure and track, but one of the simplest way to illustrate is that urban population is expected to reach 70% by the mid-century. At the same time, there is around over 800 million people suffering hunger, and maybe double that suffering malnutrition, while at the same time we are witnessing the global epidemics of obesity. Altogether, almost half of global population is not receiving adequate food. At the same time, food produce has recognized detrimental effects, and maybe in the last years, most notably, EU Commission has done a number of studies on endocrine disruptors present in food, substances which mess up the immune system and hormonal system, causing a host of systemic diseases. So at the same time, with this long list of problems, we have a highly polarized debate on how to make a transition of food systems towards sustainability. The debate can be mostly framed around sustainable intensification and agroecology. Um, some prominent organizations like United Nations Food and Agriculture Organization is promoting sustainable intensification, for example, as a broad goal, but at the same time there are other institutes highlighting that sustainable intensification corresponds to a bit more narrow set of approaches. It's usually interpreted as orbiting increased efficiency in in agricultural input and natural resource use. Both sustainable intensification and agroecology are reactions to the last agricultural revolution, so-called green revolution, and detrimental environmental effect it has. Sustainable intensification does that more in the sense mentioned of trying to increase efficiency of resource and inputs, but while agroecology is arguing more for a broader system change and focus on uh, other aspects next to food production, such as food distribution and smallholder empowerment. Um, these approaches produce divergent narratives on food systems. Narratives is maybe a particularly important word to use in this context, as there are entire stories told how the current state of unsustainability is reached in one point, in what it consists, but also what are the remedies for the crisis and targeted and vision toward which we should transform the system. Um, Two approaches have very different views on the main issues and key notions, with each of them focusing either on food production or on other food distribution and food utilization. And key notions range across the approaches from food security to land scarcity. As a consequence of these different stories and lenses to which key topics are viewed, there is resulting disagreement about common facts and, of course, their interpretation. Um, and these two approaches differ across almost any of the problems we listed in the first slide. Um, Maybe most prominent example of this disagreement is a heated debate on land sparing and land sharing. The main contest here is should we spare some land for natural habitats and biodiversity, basically, and use the intensive methods on the remaining part of global arable land. And there are arguments that this can be done, even that arable land can be reduced even by half if appropriate intensification methods are applied. That's the picture on the right. While the other side debate for integration of nature into the arable land and into the cultivated land, and having some mixture of wildlife and cultivated species at the same time, not necessarily in the same field, but in the same unit of assessment. There's a key topic which creates additional problems. What is the unit of assessment? But we'll return to that later. I want to point that this debate essentially comes to effective production methods, because based on which production methods do what, or how do we assess their consequences, we are prone to choose between these two sides. And the important limiting factor for this discussion is that there is growing consensus that there will be no new cropping methods in due time, because effectively we have new cropping methods very rarely, and probably only one in the last 40 years. And uh, even if there is a new third way of viewing this problem, is it will not be ready by 2050 for implementation and scaling, basically. So what the debate is particularly characterized by is that by different focuses the proponents put in the first place. And on one side, we have arguments which are usually orbiting production and economic efficiency as key for basically feeding the world, because the, the task here is to produce enough food in a way that minimize harm to biodiversity. And production is obviously one of the two main goals. Some some communities focus on not on food production itself, but on other methods for increasing food security, such as increasing food sovereignty, which has some drawbacks in itself, because it reduces the intensity of agricultural production, although it does favor the conservation and natural preservation goals. So particular problem from meta research perspective with the current state is in the field is that the research is becoming increasingly bipartisan, and they are both public and in the form of non-governmental organizations and independent institutes, but also academic, basically accusation of the other side for biased, irrelevant, contradictory, or in some cases even fake research. And there is a widespread oversimplification of the opponent's position, coupled with overemphasis of one own's well, concepts and research heritage. So for the rest of the presentation, we'll try to unravel some underlying causes between the disunified states of the state of the debate, and try to see what can we do about it. And it's basically a meta-level discussion, and we'll finish with some points on what kind of research, what it means for research to be good or appropriate for sustainable transformation. So what we'll do particularly is first we'll illuminate some non-empirical epistemological assumptions behind these two thought collectives. Then we will argue that epistemological and ethical assumptions cannot be always clearly differentiated, and a different take on normativity in sustainability science is needed. We're going to argue particularly for a meta-research framework called hybrid epistemic moral values, which tries to perceive these two traditionally separated spheres from one position. So in these different approaches to sustainable food systems, there is a striking contrast between how interdisciplinary research is organized, and the research communities are commonly orbiting and constituting two different groups of interdisciplinarities. And on one side, we often see dominance of scholars coming from the background of economics, agronomy, or technical sciences. And the other collective is usually presented by scholars from ecology, social sciences, and conservation science. So this can be already seen in sheer frequency of the word used, like markets, efficiency, crop yields, labor productivity, and incentives on one side, were contrasted with ecology, resilience, community, livelihoods, and rights in the other community. These different scientific languages are symptoms of different disciplinary heritages each of these communities have, and that includes many things, but among other different model building templates, target system definitions, but also prioritization of certain types of models. And a typical case of this is primacy or focus on economic versus ecological models in integrated modeling. So we'll try to unravel a bit this different disciplinary heritage, because it has maybe two most prominent categories. And on one side, it includes different methodological traditions. So sustainable intensification community usually sticks to the ideal of positivistic science, while socio-ecological science, on the other side, they are having the ideal of scientific knowledge holistic connections. In the first case, we have atomistic and mechanistic representation, championed by natural science in general, the gold standard of explanation and representation in natural science. While in this other group, more dominated by social sciences, we have focus on complex and emergent model properties. Consequently, the gold standard of methodology are experiments, quantification, and exact measurements in the first case, versus qualitative analysis and interpretive methodologies in the other case. These different methodological traditions shape different ways how we define the system we are interested in, and different definitions of problems and systems. Different systems basically have, as any system has boundaries and blinders, different definitions produce different boundaries and blinders. And a typical example in agri-food sector is choice of scale, because if, for example, if you focus on field scale, you notice some micro causes which cannot be seen if you view the entire topic from ecosystem scale. And what is missed from each of system perspective and what is left out may significantly shape what is left in. Particularly, these different system definitions consider different types of data as legitimate, and that produces a lot of, or a big part of the context mentioned at the beginning. This entire difference in scientific traditions and pertaining to certain methodologies in producing scientific knowledge is just deepening the divide in scientific worldviews and sort of perpetuating the position we started from. Important thing about modeling we want to highlight here is that there are no objective answers to which model is, in this case, is good. Is it good to model to do measurements of total year per unit of land, or to do measurements of yield per commodity, or yield per worker? And there are no objectives for these questions, because they're basically the questions of which methods and which models are the most appropriate. And as we know from general philosophy of science, to answer the question which model is appropriate depends on the question for which purpose. And with the question of purpose, and we want to transition to discussion on normativity and sustainability science. We want to argue here, first and foremost, that the very concepts we used in previous slides, making a list of different epistemological sources of controversy, can be fundamentally misleading, because it builds on the idea that epistemic and ethical dimensions can be separated in sustainability research. However, a growing debate in recent years on normativity in sustainability science show us Well, first, on the basic level, that models play a dual role of representing and intervening at the same time, because sustainability in itself is not just a descriptive concept describing the relevant socio-ecological system, but also a fundamentally normative concept um, signaling us how we should transform this system. So, as a consequence of this dual role of modeling, uh, which is inherent in sustainability science as solution-oriented science, as a consequence, if we want to generate knowledge which is relevant to achieve sustainable development, we need analytic engagement with these norms and values, and particularly the United Nations Agenda 2030 as the overarching framework or overarching set of sustainability goals and values. So there are two main points we want to make about this, how values affect research. So first of all, in philosophy, there is something known as inductive risks, which means that it's just formulation of this idea we covered in previous point, that every methodological choice has some ethical repercussions, and consequently, ethical values affect through these repercussions every methodological choice we make. And research process, not just in sustainability science, but in sciences in general, is shot through with inductive risks. Basically, at any point, we have a choice. That means that selection of research topics and questions, choice of methodology, identification of meaningful categories, indicators, thresholds, even interpretation and evaluation of data, all depend not just on epistemic considerations, but also and ultimately on sustainability values towards which we are trying to push the system. So, second point important for understanding the role of values in sustainability science is that we have a very vague definitions of what sustainability means. Sustainability as ethical values to which we are trying to change the system. So, on one hand, United Nations 2030 agenda is fundamentally ambiguous, and although it lists 17 sustainability goals, 150 something targets inside these goals, there is no clear prioritization of values, and when certain research promotes one value and contradicts some other, there is no clear directive how we should resolve this conflict. Coupled with this, almost 19% of current sustainability research do not include even a general definition of sustainability. So we have very vague idea what sustainability means on United Nations level, and in research itself, it is not always specified to be clear to actually what values particularly the research is contributing. So, as a consequence of both these issues, the vague character of sustainability values and unclear definitions of sustainability, on top of that, when we take scientific practice and take most of principles used there, it is very hard to discern what actually is a fact and what is the disguised values. Because as the quotation from Kaiser I put here, even when something looks like a fact, if one looks closer, one discovers discovers a sea of uncertainty and different weightings around it. And every time we set a threshold, it is based not just on epistemological reasons, but fundamentally of what we consider that is a threshold for sustainability. And what we base that, of course, on many times on values which are not explicit in the research process itself. On top of this, research is culturally embedded, and each scholar belongs to a certain thought style or thought collective, or however we call it, and both personally and inside of this collective tends to make a number of implicit value judgments. So instead of traditional split between um, epistemological issues, which concerns how it's best and easiest, most efficient to approach the facts, and ethical issues, which concerns values which are traditionally pushed to the political arena, we want to argue here for a hybrid epistemic moral values framework, as it seems that as induction risk is everywhere, it is more straightforward to and permeates the research on every level, wherever there is a choice. We believe it's more useful to think on facts and values as inherently mixed or hybrid. So, to return to the context of sustainable food systems, what researchers really face in each of the approaches to sustainable food systems research is a mixture of facts and values, and many disagreements which seems to concern facts cannot be clearly distinguished from some fundamental disagreement about underlying values. And maybe nicest example of this is a broad question: how to feed the global population in 2050. And research approaches argue confrontationally almost about this topic. We want just to highlight the bigger meta question, which between sustainable intensification and agroecology basically comes to the question: do we need a system change for sustainability transformation, or do we need a series of incremental efficiency improvements? What is important, we want to highlight here that how we answer this question. First, many times we don't. It's something each one of us carries into research, and it depends both from the context where we are educated, discipline to which we are proficient, but also context where we have been socialized, both privately and academically, but also from questions like who funds the research, who are the dominant stakeholders, and what are the pressures on scientists from that perspective. So to cut the story short, the main consequence of applying the hybrid framework to sustainability research is that we need to embrace heightened moral and social responsibility, particularly about our own judgments, particularly about our own implicit value judgments, and try somehow to surface and unravel this before the research itself is done. The $1,000,000 question: how do we do this? We will argue in the rest of the presentation, in the last slide actually, that we need to equip researchers with methods for identification of implicit networks of values and to trade them for value deliberation and negotiation, which are essentially political processes, and integrate this discussion of values in science itself. So, based on the idea of hybrid framework and viewing facts and values as interconnected, inherently interconnected, we are going to cover some requirements for good sustainability research coming from the hybrid framework. So, first and foremost, we need more reflexive thinking in the sense of um, explicating our own intents, motives, driving our own research, even the one which we are not aware. This may be facilitated by methods for collaborative work, but and also organizational mindfulness, just to mention some of the recent approaches towards this towards increased reflexivity in sustainability science. At the same time, we need more systemic thinking, not just in the form of acquainting researchers with abstract system thinking frameworks like game theory, but in more simple terms, thinking about other sectors, other problems which are not directly correlated with our research, but which might affect it. So when we are speaking about reducing greenhouse gas emissions, we must not just assume that the other fields will sort their sort the issues. We cannot actually source the problems to other fields. So we need questions like, okay, how are we going to run our machines? Can transition to electric agricultural machinery be accomplished in 30 years? And even that, can the energy community, does the energy community supporting this? And is there a reasonable expectation that we'll be able to produce renewable energy on this increased scale, now covering more sectors than previously? At the same time, we need to engage with complexities of the United Nations 2030 agenda. Unclear status of agenda on prioritization of values must be tackled with increased attention to particularly negative relationship between sustainable development goals, the so-called trade-offs, but specifically outside our own narrow field. And we must try to understand and assess and internalize in our research, will this create problems in the other sectors bigger than it is reasonably to expect that they will be able to solve? I want to argue that all researchers must be included in this systemic reflection, although I completely acknowledge the immense pressures on researchers coming from many sides, both from dynamics inside the scientific community itself, the pressure for more publishing, for also commercialization of science, making science useful for commercial purposes. And we must approach this from perspective of awareness, because otherwise we risk being instrumentalized by, for example, dominant stakeholders, or simply even practicing and using power without awareness. Related with the problem of being pressured by dominant stakeholders is engaging with the communities concerned as the only way to make the abstract principle from the UN Agenda 2030 concrete. We must ask questions for whom this sustainability benefits and what does it sustain. So, in summary, we need increase attention to profound and delicate ethical repercussions, but also assumptions and motives driving and guiding the research. Um, for the final point, um, I want to draw on some on work on John Ioannidis from Stanford, a leading global scholar on meta-science, and particularly on meta-science, which is also a solution-oriented, stakeholder-inclusive field like sustainability science. And I try to systematize some insights based on hybrid framework for sustainability research in general. The final point uh, coming from the table is that to suggest to scientific community to pay more attention to basic assumptions of good sustainability research. Okay, thank you.